Okay, notes 2.2a. So we look at the right-hand side and FOIL it out to see that you get the two formulas for splitting up sums and differences of cubes. Unlike squares, you don't need I or anything weird to do a sum of cubes. Okay, distributing A. And then distributing B. And most of the inner stuff cancels. Yay. Okay. And then okay. So the more important thing, of course, is breaking it up, because we're starting to do limits, and as you may remember from last year, one of the ideas is limits are a nice cheaty way of canceling things that could be zeros. And so a minus b or a plus b could be equal to 0. Speaking of which, we need to practice some factoring. If you have no middle term at all, you have to factor into two of the same thing, 1 plus and 1 minus. Oops, 1 minus. Okay. Break up the beginning, then look at the end. Here's a hint. The 3's cannot go together. Okay, so I want positive 7. So remember, this isn't really 3, it's really 9. So add 9, subtract 2, and that gives you your 7. Watch for common factors. Among other things, it keeps the numbers smaller, makes it much easier to deal with. And then also, I usually try 2 and 3 first, so okay. The 2's cannot go together, so let's try 2 and 5 this way. You look at the beginning, then you look at the end, and then you try and see if you can make things come out to the middle. So I need negative 10. Let's see, remember that's 4 and that's 15. So I think negative 15 and positive 4. Look at that, didn't take that long. As long as you remember, once you've canceled out any common factors, you can't put any lingering common factors together, and that makes it many, many fewer things. So notice this is a difference of cubes. It's 3x cubed minus 2 cubed. So I'm gonna write down my formula first. A cubed minus b cubed. We just proved that that was a minus b, a squared plus, there's only one minus sign to go around. I'll write ab rather than ba. Okay, so we've figured out that a, not a cubed, but a is 3x, and then b is going to be 2. So three a squared is 9x squared. Oh, that was terrible there. Let me try and write properly. Okay. 3x times 2 is 6x, and then 2 squared. And you're done. Yay, life is good. All right, speaking of factoring, let's factor this all out. x plus 1 and x minus 1. I didn't say anything about this, but I need 2x and 5x, so don't put the 5 across from the 2 because I don't want a 10. Also, chances are one of them is either x plus 1 or x minus 1 because it looks like we want to cancel. And it says for this can't. Now normally we can't cancel without having the weasel words limit in front, but it says for this problem, forget it, just simplify. Notice in this problem, if x is plus or minus 1, we have a vertical asymptote anyways. Foil the top out properly. And then subtract off 1. I'll write this down. So remember, you square things, you got to get the middle term. You can't just distribute the exponent. Okay, so the 1's cancel. Let me do that in blue. Binka. And the rest has a common factor of a. Remember, you can only cancel a out if you cancel out of both terms. Okay, what about this one? This one, do you remember what we did last year? Instead of dividing by x minus 3, I multiply by the reciprocal. So okay, and then I've got the numerator. Now what? Now I'm going to simplify, well, I'm going to combine the stuff on the inside. What is the common denominator? Don't look at the x minus 3, but the common denominator for the stuff we're trying to combine is 3 and x, so 3 times x, 3x. So don't forget to write the 1 over x minus 3 down. I write it first so I don't forget it. Let's see. 2/3 you multiply by x, and 2 you multiply by 3. Once you have the common denominator, you write it as a single fraction. Okay, now what? Look at 2x minus 6. 2x minus 6 is 2 times x minus 3. Oh, do the x minus 3's cancel? Yes, one's on the top, one's on the bottom. So this is grand total of 2 over 3x. And note, I'll write it in blue. So for instance, if I had 5 minus 3a on the bottom and 3a minus 5, I cancel that to just -1. You can put it on the bottom or the top or in front. We like to put it in front. Okay, this was the multiplying by the conjugate trick. Which we did when we were discovering limits last year. So I'm going to be looking at foiling this out. We have root x minus 3 times root x minus 3 is just plain x minus 3. And then just this once, I'll write it out all the way. So plus root x minus 3 for the outer and minus root x minus 3 for the inner. And then the last is minus 1. Don't distribute on the bottom. Oh, sorry, why am I turning them into x minus 1s? Whatever. They're all x plus 3s. Too early in the morning. Okay. So the square roots only cancel. X plus 3 minus 1 is x plus 2. Oh, look at that. These are all gimmicked to cancel, of course. If we just created random problems, it's hard to make things cancel. So the a's cancel, the outer and inner cancel, and then it's b squared if you don't have a square root for the second thing. If you have both square roots, then you just have a minus b. Okay. Verify that the following function has a limit as x approaches to be 3, even though f of 2 is 7. So the limit doesn't have to equal the value of the function. So we write this down by saying two things. We'll say the limit, let me do that in red. Do you remember the little minus sign means come at it from the left? In other words, numbers that are more on the left or lesser side. And that means I'm going to use the version that is for x less than 2. So plugging 2 in, I have 2 plus 1, which is 3. The left limit is 3. What about the right limit? Coming at it from the bigger side, we have 2 times thingy minus 1. And again, the thingy that I'm plugging in is this value that I'm testing. And it's also 3. Since they're the same thing, okay, so they were both 3, so we say the limit as x approaches 2 of f of x is 3. Now you may remember what the picture looks like for this. X plus 1 looks like this, but we only draw it until x equals 2. Put a hole. Then there's just this random height. Oops, sorry. I pushed the erase button with my fist. You go up to 7, plant a single dot, and then you do 2x minus 1, which is a steeper curve, also has a height of 3. And so this piecewise function has just this place where it's a discontinuity, but it's called a removable discontinuity. Okay, so I'll write a little note. Okay, the value of the function can either be just a distinct point, which is what we did, or it can just be not there at all. It's still going to have the limits. Okay. Ooh, I did this with 16 and 4. I don't have my calculator with it, so then I'm just going to make this 16 and 4. The only reason is with 9 and 3 it was bug ugly decimals, whereas this is slightly less bug ugly decimals. Okay, I'm going to try 0.1 and also 0.01, and we have to do both sides. So what I'm going to do is, oh, you know what I actually did, just say this. What you want to do is plot numbers, pick numbers really close to 0. I guess what I did was 0.01 and 0.001, but you have to remember to try it from both sides. So 0.01 when you graph and trace, I got 0.12498, and when I traced at negative 0.01, I got 0.1250195. Fine. So, are we close to a particular number? Well, let's try even closer. And what I say is my estimate looks like I'm heading in on 0.125. That's also known as, incidentally, 1/8. So, okay. I also did, let's see, can't do 0.01. This time I need to get 1.01, I think. And then the good question, what's closer on the other side? Not negative 1.001, that's way far away. Let me just write these down. What's just to the left of 1? 0.9. Yeah, 0.99, 0.999. I'm going to say my estimate is 0.8.